You are getting 48 mega hashes per second when mining Ethereum on an A2000? That sounds too good to be true. So from what I heard, all you need is a GPU, a soldering iron, a few bits and bobs. What possibly could go wrong? What is up, miners, and welcome back to the 3Fox Company YouTube channel. That intro might sound a bit cheesy, but getting 48 mega hashes per second on your A2000 when mining Ethereum is no joke. As a matter of fact, it might be easier than you think if you pay attention to this video and you practice your rusty soldering skills of electronic components that's smaller than anything you attempted before. In this video, I will show you step by step how to modify your A2000 so that you can increase its performance even more while retaining its jaw-dropping efficiency. But before we start, please note that this should only be attempted if you feel confident in your soldering skills. Modifying electronic devices carries significant risk, so just keep this in mind. Also note that you might brick or damage your GPU beyond repair. Step 1. Tools, components and consumables. You will need both a TX6 and TX7 Torx screwdriver to remove the front plate and the cooler shroud from the PC board. Next, I highly advise you to use flux, like this flux pen that I have here, when soldering these tiny components, as it helps the new solder to easily flow and create a better joint. Now the actual star of the show that will do its magic is the 5 milliohm surface mount resistor. These are freely available, but make sure that you get the correct size and wattage, as you do get these in many different sizes. Lastly, you will need a soldering iron of suitable size for the task at hand, of course, as well as thin, good quality soldering wire. Step 2. Disassembly of the GPU. With the GPU on the work table, find the tiny screws on the PC board that secures the fan shroud onto it. There are 6 screws on the PC board itself, which you carefully remove. There are also another 2 screws on the front plate, which is slightly larger in size, so use the bigger Torx screwdriver when removing these. With all the screws removed, the fan shroud comes off quite easily. Pay attention to the fan connector when removing the shroud and unplug it from the PC board connector. The connector is quite tight, so care must be taken not to damage it or damage the fan cables. Step 3. Planning the job. With the PC board on the table, it is very important to identify the correct resistor that will be modified. There is an identical resistor on the outside of the PC board, but we are only going to modify the one that's on the inside that is situated next to the memory heatsink. Also find a comfortable position for your hands and the PC board orientation when doing the soldering, where you have easy access for the soldering tip to the soldering surface. Step number 4. Doing the actual job. Okay, so you practice your soldering and desoldering skills of components on your friend's PlayStation. Now it's time to place the new resistor on top of the existing resistor and add a little bit of flux to the equation. Don't worry if you use a little bit more than anticipated, as it is non-conductive and won't damage anything. Add plenty of soldering wire to the tip of the soldering iron, hold the new resistor in position with some tweezers, and make a committed attempt to fuse the 2 components together on the one side. You can also use a clip of some sort to keep the resistors together and then add the soldering wire only when introducing heat to the components. It is basically 2 different methods and you can decide which works best for you. Keep in mind that most electronic components are temperature sensitive and the time that you spend introducing heat should be limited as much as possible. It is good practice to only spend enough time on the component that will produce a good joint and then let it cool down naturally. This is very important. If you spend too much time introducing heat to the PC board in one spot, you could damage the component, or you could even separate the copper tracks from the board, which will make your GPU a very expensive paperweight. Once the one side is done, repeat this step on the opposite side of the resistors, inspecting the soldering joints closely and ensure that each joint is proper and that you do not have any possible dry joints. Now that the mod is done, it is highly advisable to replace the thermal pads with high quality ones or even the copper mods, as the increase in power will most probably make your GPU even hotter than a strip club in Thailand. Putting the GPU back together is as simple as taking it apart. plug the cooling fan connector back into the PC board connector, place the fan shroud on top of the PC board and reinstall the tiny screws, as well as the front plate. Now the time for testing has arrived. This is the exciting part to see if we have done the mod correctly or if we will end up with an explosion or a pile of molten plastic and silicon on top of our test bench PC. Now we're in iOS. As you can see, I added the A2000 to my 3060 LHR version 2 rig, which will be an interesting comparison as the A2000 and the 3060 doing about the same hash rate on Ethereum. So let's first use the overclock that we previously had when the GPU was stock to see if we can actually run the GPU like before should we encounter any temperature issues. I set the locked core clock to 970 and the memory to 3200. This is the setting that I used previously, so let's give it some time to run a few cycles and I will update you accordingly. As expected, it is running 42.09 megahashes per second, which is the same as before. The temperatures are actually better than previously, since I went ahead and replaced the thermal pads while the GPU was open. Now we have a few options on how we would like to run our GPU. If cooling is an issue, you can run it on lower memory overclock, or if you want maximum performance, then you can push the memory quite high. So let's change the overclock and see what the GPU can do. Firstly, I will set the locked core clock to 1155 because I'm trying to keep the wattage below 85 watts. Remember that the A2000 does not have any external power supply, so all the power is fed through the PCIe riser, which is only rated for 75 watts. I will be using 5200 for the memory overclock, which should give us around 48 megahashes per second. So let's run it for a few cycles and see what we get. I am now in Hive Shell and our A2000 is doing great. The temperatures have settled around 65 degrees Celsius for the core and 82 degrees Celsius for the memory with a fan speed of 99%. Note that I'm using auto fan function with a core target temperature of 62 degrees Celsius. We are getting 48.13 megahashes at 81 watts as expected with an efficiency of 594 kilohashes per watt. Also note that the wattage that I reported in the miner is pretty accurate as I'm also measuring it with my Elmore Labs PMD and the measured wattage and the displayed wattage is the same. Let's go back to iOS and let's push the memory a bit and see what hash rate we can get. So let's take the memory overclock up to 5800. I will be leaving the core at 1155 and again let's run it for a few cycles and see what we get. We run it now for a few cycles. If we go back to the miner, we can see that the hash rate settled on 49.91 megahashes per second at 83 watts, which gives us an efficiency of 601 kilohashes per watt, which is awesome. Also, the temperature is still at 65 degrees on the core and 82 degrees Celsius on the memory with a fan speed of 99%. So basically we can get 48 to 50 megahashes per second on this modified A2000 depending on how well the GPU is cooled. If your GPU runs a bit hot, it would be preferred to run it at a lower memory overclock, but if temperature is not an issue, then you can push it slightly over 50 megahashes per second. If you enjoyed the video, please smash that like button and consider subscribing to the channel. If you haven't seen this video or this video, please make sure to watch them next. And as always, stay safe, stay healthy, and I will see you in the next video.